Welcome back to our Computer Systems unit. In this topic, we will look at the computer structure. As always, we have some learning intentions. In today's lesson, we will look at the concept of the fetch-execute cycle. We'll look at memory read and memory write operations. And we'll also learn about the factors that influence computer system performance. As always, we have some success criteria for the lesson. You should use this as a tool and refer to it throughout the lesson. You should use this to assess your progress within the lesson. The basic operations of a computer system is called the fetch-execute cycle. The CPU is designed to understand a set of instructions or an instruction set. It fetches the instructions from the main memory and executes them. This is done repeatedly from when the computer is booted up to when it shuts down. Let's look in a little more detail. The CPU fetches the instructions one at a time from the main memory into the registers on the CPU. The control unit within the CPU decodes the instruction. The control unit executes the instruction. And this is repeated until there are no more instructions left. Now let's look at a couple of detailed operations. We'll start with a memory read operation. In step 1, the memory address of the next instruction is placed on the address bus. The read line is then activated on the control bus. The data bus is set up with the data to be read. The instruction is transferred to the processor on the data bus. And the instruction is decoded and executed. We'll now look at a memory write operation. Again, the memory address of the memory location to be written to is placed on the address bus. The data bus is set up with the data to be written. The write line is activated on the control bus. The data on the data bus is transferred to and placed in the memory location specified by the address bus. Now let's look at factors that impact on system performance. We'll start with clock speed. CPUs can only carry out one instruction at a time. It seems like CPUs can perform many instructions at the same time. However, the CPU is able to carry out instructions so quickly that it can seem like it is simultaneous. The speed at which the CPU can carry out instructions is called a clock speed. It is controlled by a clock. With every pulse of the clock, the CPU fetches and executes one instruction. The clock speed is measured in cycles per second, and 1 cycle per second is known as 1 Hz. This means that a CPU with a clock speed of 2 GHz can carry out 2,000 million or 2 billion cycles per second. Another factor that can impact on system performance is data bus width, sometimes known as word size. The data bus is a collection of electronic lines that connect the CPU and main memory. With every pulse of the clock, the CPU fetches and executes one instruction. The data bus width determines how many bits of information can be transferred to the CPU with every clock pulse. The larger the data bus width, then the greater the amount of data that can be transferred. This significantly increases system performance. Another factor that can impact on system performance are the number of cores a processor has. A CPU can contain one or more processing units, and each of those units is called a core. Each core will have its own arithmetic and logic unit, control unit, and registers. It is common for computers to have dual or quad core processors. Dual meaning 2 or quad meaning 4 cores. CPUs with multiple cores have more power, and they can run multiple programs at the same time, with each core executing its own instructions and carrying out its own processes. However, if we double the number of cores, this does not mean that we double the computer's speed. CPU cores have to communicate with each other through channels, and this uses up some of that extra speed. So in conclusion, if we increase the number of cores in a processor, there will be an increase in system performance. The final factor we will look at that impacts on system performance is cache memory. Cache memory temporarily stores information, data, and programs that are commonly used by the CPU. When data is required, the CPU will automatically turn to cache memory in search of faster data access. This is because RAM is slower and is further away from the CPU. When data is found in cache memory, this is called a cache hit. A cache hit enables the processor to retrieve data quickly, making your overall system performance more efficient. Since cache memory is so much smaller than RAM, the data it stores is only temporary, and as such, it may not hold the information that the processor needs. The processor accesses cache from level 1 through 3 before accessing RAM. When the cache does not have the processor's required data, this is called a cache miss. And in this instance, the CPU will move on to RAM and the hard drive. Let's look at this in an example. The CPU tries to locate the required data or instruction in level 1 cache. This is physically on the same chip, so it will be the fastest memory to access. If successful, this is called a cache hit. If unsuccessful, it will then try to locate it in level 2 cache, which is larger but slower to access. If the data or instructions are still not available, the CPU will try to locate them in level 3 cache. If the CPU is unable to locate the data or instructions in cache, this is called a cache miss. It will then go to RAM in order to access the data. This is a significantly slower process when it comes to system performance. Thank you for listening. Please subscribe to our YouTube channel and click the notifications button to be kept up to date with our latest materials.